let n be the number of consecutive zeros at the right end of the decimal representation of the product of factorials from 1 to 100. Find the remainder when n is divided by 1,000. So the thing to recall about these sort of problems is a 0 at the end of any number is generated by a factor pair, a pair of 2 times 5. Why is this? Well, any 0 at the end of any number is equivalent to multiplication by 10. So for there to be a 0 at the end of a number, there must be a factor pair of 2 and 5 in the prime factorization of that number, since the prime factorization of 10 is 2 times 5. It's clear that if you look here, the number of 2's in this factorization is much larger than the number of 5's. So we need only count the number of 5's because we can easily find a 2 to pair with it. So in order to do this, note that 96 have a factor of 5. So this is how I will denote my notation. This denotes having a factor of 5, F5. So 96 have a factor of 5. Then you can note that 91 have a factor of 10. And I'm getting this by noting that every number past 5 factorial and past should have a factor of 5. And similarly, every number 10 factorial and past should have a factor of 10. And if you continue this, you get an arithmetic series that goes all the way down to 1. So the sum of this arithmetic series is straightforward. 1 plus 6 plus 91 plus 6. I'll leave this to you, but you can verify that this evaluates to 970. Now you'd be tempted to put this as the answer and move on, but you have to note that there are cases we haven't accounted for, right? Because the case where n has a factor of 25, in this case, we have to add another factor of 5 because 25 is 5 squared. So to add on certain cases, so this is just factors of this case, we have counted just the factors of k times 5 to the first power. Now we have to count the factors of k times 5 to 5 squared and so on. So 25 is 5 squared. And you can note that all n greater than 25, when n represents the factorial of each of these, all n greater than 25 will have a factor of 25. And the number of such n is 76. Similarly, n greater than 50 will have a factor of 25, and the number of such n is 51. And similarly, n greater than 75 will have a factor of 25, and the number of this is 26. And finally, arbitrary color change, n greater than or equal to 100 should have another factor of 25, which is 1, since there are only 100 numbers. So to find our total count, we simply add all these numbers, these numbers, and upon adding them, you can find that this sum evaluates to, let's see, 76 plus 26, that's 102, plus 52, 4154, plus 970, 1124. So the remainder when n is divided by 1,000 is 124.